Okay, this is Trig Identities Part 2. I'll be doing these problems here, and you will, I will probably do a Part 3 as well. The first one we have is number 21. The only thing you have to know about this one is very easy. You have to know your even-odd properties. Since tan is an odd function, we're going to use the odd property. An odd property says that tan of negative theta equals negative tan of theta. So that applies for the square as well. So all we're going to do is simplify this side of the equation. We get 1 minus tan squared of theta equals secant squared. We know from our identities that this equals secant squared. You can just write that this was based on identities. Or just write identity. So we get secant squared equals secant squared. And we got to check. The next one is 31. We're going to go ahead and distribute here. There's not much we can do with that. So I'm going to work on this side of the equation. When I distribute, I get cosine squared plus cosine squared tan squared equals 1. Still, not much I can do there. I can write this as cosine squared plus cosine squared times sine squared over cosine squared. Alright, and then we get cosine squared. Here, these two cancel. So we get plus sine squared equals 1. And we know from our identities, that cosine squared plus sine squared equals 1. So we have 1 equals 1. Okay, and this one is based on the fact that a minus b times a plus b equals a squared minus b squared. So that's what I'm going to do here. I'm just going to write this as secant squared minus tan squared equals 1. And since this is an identity, we have 1 equals 1. Okay, this one is a little more complicated. I think our first reaction is to write this in terms of sine and cosine. But a lot of times I already know my identities, that secant squared minus 1 equals tan squared, so I'm not going to do that. I think I'm going to take this first piece and factor out, use the greatest common factor. By the way, in math studies and math SL, they call it the highest common factor. Same thing. So we can divide both of these by secant squared. So I'm just going to pull secant squared out, and I'm going to get secant squared minus 1. Okay? So we know that secant squared equals tan squared plus 1. This is what, 35? So this equals tan squared plus 1. So this was this piece. This piece, we know, equals tan squared. Now when I distribute, I'm distributing from the right here. I'm going to get tan to the 4th plus tan squared. So these two match. You could have probably taken this side and did the same thing and got your left-hand side here. Like I said, there's no exactly right and wrong way to do these. If you'd have changed all these to sine and cosine, it would have been a lot more complicated, however. The fact that you know your identities, this is based on identities here, made it easier. Okay. This one. I'm definitely going to rewrite these here in terms of sine and cosine. So I'm going to rewrite with sine and cosine. So secant I know is 1 over cosine. And I know tangent is sine over cosine. Now if I rewrite this with the same denominator, I get 1 minus sine over cosine. Now if you recall, when you did your number 12, that these two can be equivalent if we multiply by the conjugate. So what I'm going to do here is use the conjugate, and you can't just say these equal. You have to show me that these equal. So I'm going to put the conjugate here. So I'm going to write 1 minus sine over cosine, and I'm going to multiply the numerator by the conjugate, which the numerator, so I'm going to multiply this by 1 plus sine, and the denominator by 1 plus sine. When you do that, you're going to get 1 minus sine squared, and on the bottom you're going to get cosine plus cosine sine. So that leaves us cosine squared over, and I'm going to pull out here the cosine. So cosine over 1 minus sine, or 1 plus sine, sorry. Now basically all I'm going to do here, this was, I used the greatest common factor from here to here. I'm going to rewrite this as cosine times cosine over cosine times 1 plus sine. These cosines cancel, so I get cosine over 1 plus sine, which equals right here. Okay, so you can't just jump from here to here. You have to multiply by the conjugate, like we did on, I did on 11 and you did on number 12. Okay. On all of these identities, when you're establishing an identity, you always have to keep in mind what we're looking for. So we're looking to do something like this. That means this does not have a sign in it, but this does. So I think what I'm going to do, I'm going to rewrite sine. So rewrite sine, or sine squared, as 1 minus cosine squared. I think that would just make it easier. So I'm going to have 3 times 1 minus cosine squared plus 4 cosine squared. Now when I distribute, I get 3 minus 3 cosine squared plus 4 cosine squared. I can combine these two here, so that's going to be 3 plus cosine squared theta. So I have these equaling with 3 plus cosine squared. Okay, I think the book did this one a little different. But if you just know how to do this, it made it a lot easier. And I think that's the last one. The next part 3 is going to be the harder ones.